This common struggle is precisely the problem version control was created to solve. Think of it as an intelligent safety net and a detailed time machine for your entire project. It's a system that meticulously records every change you make to a file or set of files over time, giving you a complete, reliable history of your work. So, how is this different from just using Dropbox or Google Drive? While cloud storage services are great for backups and sharing, they typically just sync the latest version of a file. Version control, on the other hand, understands the content of your files and records the specific line-by-line changes, creating a structured history of snapshots in time. Now that we understand the what, let's introduce the most popular version control system in the world, Git. While there are others, Git is the modern standard, and it's the tool we'll use to explore the core concepts. The first concept we need to grasp is the repository, or repo for short. The repository is the heart of your project in Git. It's essentially a dedicated folder that contains all your project files, code, images, documents, and, most importantly, a hidden subfolder that stores the entire history of every change ever made. This self-contained vault is your single source of truth. To understand how Git works, you need to know about its three fundamental zones. The first is the working directory. This is your project folder, the space where you actively create, edit, and delete files. It's your live, interactive workspace, but changes here are not yet recorded in the project's history. After you've made some changes in your working directory, you need to choose which of those changes you want to save in your next snapshot. This is where the second zone, the staging area or index, comes in. It acts as a drafting table, allowing you to carefully select and group related changes together before finalizing them. Once your changes are in the staging area, you're ready to permanently record them. This action is called a commit, and it saves your staged snapshot into the third zone, the repository history. A commit is a permanent, documented record in your project's timeline, complete with a unique ID and a descriptive message. Let's visualize this entire workflow. You start by modifying files in your working directory. You then use the git add command to move specific changes to the staging area. Finally, you use the git commit command to take everything in the staging area and create a permanent snapshot in your repository. This two-step process gives you precise control. Now we unlock the first true superpower of version control, project time travel. Every commit you make is a saved point you can return to. If you introduce a bug or delete something important, you can easily view the entire history of commits and revert your project back to any previous state, providing ultimate peace of mind. The second superpower is safe experimentation, made possible by a concept called branching. Imagine your project's main history as the trunk of a tree. When you want to try out a new feature or fix a complex bug, you can create a new branch to work on. This gives you an isolated copy of the project where you can experiment freely. Working on a branch is just like working on the main project. You still make commits to save your progress. The key difference is that your new history is being built on this separate line of development. The main branch remains untouched, stable, and ready for release, while you perfect your new feature in isolation. Once your experiment on the branch is successful and fully tested, you'll want to integrate it back into the main project. This process is called a merge. Git intelligently takes the changes from your feature branch and combines them into the main branch, creating a new merge commit that unifies the two histories. So far, everything we've discussed happens on your own computer, in your local repository. But the true power of Git is unlocked when we collaborate. To do this, we introduce a remote repository, which is a version of your project hosted on a server, typically on a service like GitHub, GitLab, or Bitbucket. To share your work with the team, you push your committed changes from your local repository up to the remote repository. This uploads your new commits, making them available to everyone else. This is how your contributions become part of the shared project history. Conversely, to get the latest updates from your teammates, you pull changes from the remote repository down to your local copy. This fetches any new commits made by others and automatically merges them into your local workspace, ensuring you're always working with the most up-to-date version of the project. This pull, work, push cycle is the heartbeat of collaborative development. But what happens if you and a teammate change the exact same line of code in the same file? When you try to merge these changes, Git will pause and report a merge conflict. This isn't an error, it's Git asking for your help. Resolving a conflict simply means you have to look at the competing changes marked by Git and decide which version to keep, or manually edit the file to combine both changes. Once you've cleaned up the file and saved it, you tell Git the conflict is resolved and you can complete the merge. It's a manual step that ensures the final code is correct. Let's recap our journey. We started in the chaos of manual file versions. We then discovered version control with Git, which organizes our project in a repository. We learned the local workflow of adding and committing changes, and unlocked the superpowers of time travel with commits and safe experimentation with branches and merges. From there, we expanded into collaboration, using a remote repository as our team's central hub. We learned the essential push and pull workflow to synchronize our work, and we demystified merge conflicts, turning them from a scary error into a manageable task. This complete workflow is the foundation of modern software development and collaborative projects. Mastering version control is one of the most valuable skills you can learn, not just for coding, but for any digital project, from writing a book to managing design assets. It brings order, safety, and powerful collaboration to your work. Your journey from chaos to control is now complete, and you're ready to start your own projects with confidence.